Alright, so in this video we're going to be talking about multiplying and dividing radical expressions. So in the last section you learned how to simplify, and you're still going to need those skills from that section. This time you're just going to multiply or divide first, and then use those simplifying skills to get a final answer. So again, in this section you're going to be able to multiply and divide radical expressions. So the first thing that you need to understand is that in order to combine radical expressions when you're multiplying, you must have the same index. So whether you're taking the square root, the third root, the cubed root, whatever number it is, you have to have the same index for whatever you're multiplying. So in this case, we're multiplying the nth root of a times the nth root of b, and that's the same as the nth root of a times b, both under the radical. So either way, they're going to both end up under the radical with the same index. So let's practice one of those. So in this case, it's asking you, can you simplify the product of the rational expressions? And you can see in this one that this is not possible. We're not allowed to multiply these together, because in this one I have an index of 3, and in this one I have an index of 2, because it's not written there. So you actually can't even simplify that problem. In this one, the first thing you look at again is the index, and they both have an index of 3, so that's good. So that means that our answer is also going to have an index of 3. And you're just going to multiply both things, the radicands, together. So negative 4 times 2 would be negative 8. Well, now you have something that you can simplify. And we know that if you're taking the cube root of negative 8, and we've already talked about that it's going to be negative 2. Quick refresher, remember that you're trying to find some number raised to the third power that's equal to negative 8, and that number raised to the third power is negative 2 is equal to negative 8. So again, we're going to have variables in the expressions, and when you have a variable in the expression, you don't know what the number is, so you have to look at the power that it's raised to in order to take it out. So let's look at this one first. And we can rewrite, we always want to rewrite things in terms of a third power if we can. 54 cannot be written as anything to the third power, but I can write 54 as 27 times 2, and then x to the 5th. And then 27 can be written as a third power. So that's really the same as 3 to the third power times 2. And watch carefully, I'm going to split up this variable here. It's x to the 5th. I'm going to make it x to the 3rd times x squared. So now, and I'll change colors here, we can take, there should be a 3 here, third root. We can take this out pretty easily, and we can take this out really easily. So now your answer is going to turn into 3x, the 3 from here, the x from here, so now those are gone, times the third root of whatever's left over, 2x squared. So this would be your answer for this problem. So now let's try this one. So again, the index is 3, we're taking the third root, and 128 is not a perfect cube, but I could rewrite it as the cube root of 64 times 2 times x to the 7th, and that's really the same as taking the cube root of 4 to the 3rd times 2 times x to the 3rd times x to the 3rd times x. And again, I'll switch colors again. This is going to come out evenly, this will come out evenly, and that will come out evenly. So I'll start with those. I'm going to write the 4, and then I'm going to take one x and another x, so that's going to be x squared times the third root of whatever's left over. This and this are left over, so 2x goes inside the little house. When you're multiplying products together, you're still going to do the same thing. You're going to multiply everything underneath first and then simplify as much as possible. So let's do that. If I multiply everything underneath first, I'm going to get the square root, we like square roots, they're pretty easy, of 720 times x to the 4th, y to the 5th. And then we can break this down, and that's really the same thing as 144 times 5, x to the 4th, y to the 5th. And then we know that we can take the square root of 144, and that's going to be 12. I'm going to pull out how many x's from here? 2 of them. And how many y's would I be able to pull out from here? 2 of those. And we have to figure out what's left over still. Well, the 5 is still left over. And I do still have 1 y, so that has to stay under the square root as well. So this becomes your final answer. Do the same thing and try this problem here. You're multiplying both of those together. So the easy part is putting everything under the same radical. This is going to be 1575 x to the 6th, y to the 7th. And the tricky part is figuring out what this actually breaks into. And that really breaks into 225 times 7, x to the 6th, y to the 7th. And the square root of 225 is 15, so that's going to be 15. I'm trying to take out as many doubles of x's as I can from here, and that would give me 3 of them, so x to the 3rd. And I'm going to try to take out as many doubles of y's as I can here, and that would give me 3 of those. What's left over? A 7 and a y. So 7y goes underneath the radical. And this becomes your final answer. So that was all multiplying. Now we're dividing, and it's very similar in order to divide. Again, you need to have the same indexes. And this is going to go both ways. So you can start with this and rewrite it to look like that. But in some cases, you'll have a problem that looks like this, and you're going to want to rewrite it separately like that, so you can simplify a little bit more easy. And we'll do some problems of both. So in the first problems, you're going to want to combine them to simplify first. So the rule from the previous slide says that I can do this, put a big square root over this, and this is 18 x to the 5th over 2x to the 3rd. And if I simplify within the radical first, that's going to give me the square root of 18 divided by 2 is 9. And if I have 5 x's on the top and only 3 x's on the bottom, that means I'm going to have 2 x's on the top and nothing left on the bottom. So I've simplified to this, and now it's become really easy to take the square root. The square root of 9 is 3, and the square root of x squared is just x, so your answer is 3x. We're going to do the same thing for letter B to make it a little more simpler. This time our index is 3 though, so we got to be careful of that once we get to the very end. So I rewrite it as 1 fraction, and then I can do the math really quickly to decide that 162 divided by 3 is 54, so I'm going to have the 3rd root of 54. And I have more y's on the top than on the bottom. How many more? I have 3 more. And so now we've run into the problem again where 54 is not a perfect cube. So I'm going to have to rewrite as cube root of 54 can be written as 27 times 2, y to the 3rd. So then I can pull out my 3 here, because remember 27, and I'll do this in a different color, 27 is the same as 3 cubed. So I can pull out a 3. I can also pull out a y from here. And now I'm left with the 3rd root of 2. So this would be my final answer. Be really, really careful when you're writing your answers that your index doesn't start to look like one of your numbers on the outside. So I want to be able to clearly tell that you're telling me that the index is 3 and you're not multiplying 3 times y times 3. You're saying 3y times the third root of 2. So make sure it's really clear when you write, especially on tests and quizzes, so when I'm grading I know. So take a second to try this one, and I'll give you a couple of seconds, pause the video if you need to, and I'll put up the answer in a second. And there's the answer for you to that problem. That was a pretty easy one, actually. Okay, so you've probably talked about this a little bit in geometry before and maybe possibly in Algebra 1, but there's such a thing called rationalizing the denominator. So the most simplified version of an answer is one that does not have a radical in the denominator. So if you end up with this, 1 over the square root of 2 for an answer for anything, you absolutely cannot leave it like that. You have to rationalize the denominator so that you have a whole number or a decimal on the bottom, not an irrational number like the square root of 2. And the way we do that is to multiply by 1. But 1 looks differently. Remember, 1 is anything itself, something over itself is always 1. So whatever's on the bottom, we want to multiply by something that's going to give us a whole number. And that something that's going to give us a whole number is the square root of 2 over the square root of 2. Then I can multiply across the top and get root 2, multiply across the bottom and get 2. So now you've rationalized your denominator, and these two things actually mean the same. We just like this answer better. So let's try a problem. And this is a multiple choice problem, but I'm actually going to cover up the answers first so it looks a little less confusing. And then we'll go back and look at the answers after. So this time you're taking the cube root of this problem. So just by looking at it, it doesn't look like there's really any simplifying that we can do. So what I actually want to do is split up the problem. So I'm going to rewrite it as the cube root of 5x squared divided by the cubed root of 12y squared z. And I'm going to multiply that by something that's going to make this not have any type of radical in the denominator. So right away we know it has to have the same index because we're multiplying them together, so you can start with that. This is the way I do every single problem, and you'll see a bunch of different methods, but I think this is the easiest to understand. How many 12s do I have under my cube root? There's only 1 there. But in order to pull a 12 out of the cubed root, I need to have 3 of them. I only have 1, so I have to multiply by 2 more. So I'm going to do 12 squared, 2 more 12s. Then I'm going to look at the y's. How many y's do I need to be able to pull a y out when I'm taking the cubed root? I need to have 3. But right now I only have 1. I only have 2 right now, so I'm going to put 1 more in here to make it 3 when I multiply them together. Then I look at z. How many z's do I need to take out? When I have a cubed root, I need 3 of them. I only have 1, so I'm going to put 2 over here. And in order to multiply by 1, you have to multiply by something over itself. So all I'm going to do is rewrite exactly what I wrote on the bottom, on the top. And I'll show you why this works. I'm going to start with the bottom first. I'm going to ignore the top for right now. I have the cube root, indexes are the same, so I'm allowed to do this. 12 to the third, y to the third, z to the third. So now I'm still working with just the denominator. I can pull each of these out. 12 out, a y out, and a z out, because I have 3 of them under a cubed root. So that's what I'm going to do. 12, a y, and a z. And I don't have to worry about a radical expression at all. So now I got to go back and fix my numerator. So again, they have the same index, so I'm going to leave it the same index. The cubed root of 5 times 12 squared. So that's really 144, right? And 144 times 5 is 720, I believe. Then I have two x's, so those are going to stay the same, x squared. I have a y, and I have a z squared. So now I can simplify this. So again, it's going to take some practice learning how to figure out which numbers can be simplified, but I do know that 720 can be simplified, the cubed root of 720 is the same as that. So I'm going to take this and replace it here. And I'm going to do 2 cubed root of 90 times x squared y z squared. And there's nothing else that I can pull out underneath my radical here. So my one last step is to simplify my ending. I do have something I can simplify, so I do have to do this last step. Cubed root of 90 x squared y z squared all over 6yz. So this would be your final answer, and just to check, I'll move this and see. And it looks like, oops, it looks like A will be our final answer here. Here's a problem for you to try. Take a second, pause the video, try this problem. I'll put the answers up in just a second. Alright, and here's the answer to number 5, and I want to just really quickly explain it. So this one I rewrote the problem. I want to rationalize the denominator, so I need to figure out how many more 5s do I need to be able to take one out. I have 1, so that means I need 2 more, so I have 5 squared. I need 3 y's to be able to take 1 out. I have 2, so I need 1 more. And in order to multiply by 1, I have to multiply by the same thing on the top and the bottom. I multiply my denominator across the bottom. I had 5 cubed, so I took out a 5. Then I had y cubed, so I took out a y. And then all I did across the top was multiply. 7 times 25, right, because 5 squared is 25. 25 times 7 is 175. And then I have an x and a y, so I have x times y. This would be your final answer. Finally, I want you to try some of these problems. Pause the video here, try all of these problems, and I will put up the answers in just a second. Alright, and here are your answers to numbers 1 through 6. Square root of 10, negative 3 times the third root of 4. Number 3 and 4 are not allowed. 3 is not allowed because you cannot combine these two. They have different indexes. 4 is not allowed because we're never allowed to take the square root of a negative number in order to get a real answer. Remember, that gives us an imaginary answer. And we're talking about only real numbers here. In number 5, if you simplify first, you get the cubed root of 3x. And in number 6, simplify first, you actually get the square root of 3x to the 5th. But remember, it's a square root, so you can take 2 of those x's out and you're left with 1 left inside, so you really get x squared. Sorry, I should have made that look more like x squared and not the index. That should be x squared times the square root of 3x. And that's going to be it for the video today. Make sure you have all of your notes completed. I'll be checking them during the next class.